One of the most eagerly anticipated astronomical events is the supernova of Betelgeuse in the well-known shoulder of Orion. Betelgeuse is a red supergiant star that is close to the end of its life. It is one of the shiniest stars in the night sky, but it mysteriously began to wane in the latter part of 2019. Observers even wondered whether Betelgeuse was dying. As this star draws closer to the end of its life, it is at the point of exploding. Stay till the end to find out how the Betelgeuse explosion will not affect life on Earth. Welcome to our channel, where we provide you with facts related to space and technology. Before heading on to the video, make sure to like this video, subscribe to the channel, and hit the bell icon so you may never miss any of our updates. Alpha Orionis, the bright star that regal Orion orbits, is brighter than Betelgeuse, but because of its name, brightness, size, and reddish tint, it is also one of the most famous stars. Betelgeuse is the 10th brightest star overall in the sky. Given that Orion is frequently associated with a giant, warrior, hunter, god, or other anthropomorphic animal figure in ancient mythology. Only 200 red supergiant stars have been detected in our galaxy, with Betelgeuse being the red supergiant star nearest to Earth. The star is about 16.5 times as enormous as the Sun. This supergiant star is visible from 548 light-years away and has 126,000 solar luminosities. Betelgeuse ends up losing about 1 solar mass every 10,000 years. A nebula surrounds the red star because this material is being ejected unevenly from the star in all directions. When a star is born, it is made of hydrogen, which fuses in the star's core under the force of gravity to create helium in a nuclear explosion. Betelgeuse is estimated to be between 9 to 10 million years old. As the star ages, its primary fuel hydrogen runs out, and helium begins to combine with carbon to form carbon. When the helium is used up, neon will ultimately combine with carbon to form iron. During the fusion process, a lot of heat and light energy is typically released. This energy travels to the star's surface and it is released as a photon into space. Since there is nothing to resist the star's extremely strong gravity when iron starts to fuse, this causes the fusion of neon with iron to absorb energy rather than release it, causing the star to collapse in on itself and generate a supernova explosion. Supernovas, one of nature's most potent forces, have an energy output equivalent to 10 billion suns. Based on the stage of their stellar evolution they have reached, stars change throughout their existence from the youngest, hottest blue forms to the older, cooler red kinds. Strangely, the ruddiness of Betelgeuse's colour was described by Greek astronomers from 90 to 168 AD, but 3 millennia ago. Betelgeuse is only about 10 million years old. It is undoubtedly approaching the end of its lifespan. A supernova may occur soon because Betelgeuse is nearing the end of its life. However, the exact timing of Betelgeuse's supernova is widely debated. Betelgeuse experiences 2 dimming and brightening cycles, the second of which lasts about 100 days and happens about every 5 years. It is believed that during this cycle, the star's outer shell will expand and contract, affecting the star's circumference and average temperature as the cycle progresses. Betelgeuse dimmed unevenly between 2019 and 2020 before briefly returning to its normal brilliance, which attracted a lot of attention. Astronomers believe it might be a sign that the star is close to dying. Betelgeuse was evicted from its home Orion OB1 association, which includes the stars in Orion's belt, and has been observed moving through the interstellar medium at a speed of 30 kilometers per second. This speeding star is producing a bow shock that is more than 4 light-years wide. The circumstellar envelope, which is made of material ejected from the star and emits and absorbs light, makes it challenging to define Betelgeuse's photosphere because Betelgeuse is a pulsating star, causing its diameter to change over time. Optical emissions also shift in color and weaken with distance from the center due to limb darkening, leaving no clearly defined edge to the star. It's challenging to compare electromagnetic spectrum observations since the star's apparent size varies depending on the wavelength used. Different wavelengths can be used for measurements, and the reported diameters can vary up to 35%. Astronomers have found at least 6 shells orbiting Betelgeuse. The intricate dynamics of Betelgeuse's extended atmosphere have come under scrutiny. Hubble and other observatories were used by astronomers to find that the star produced a massive surface mass ejection in 2019 and rejected a significant portion of its visible surface. This behaviour has never been observed in a star. Our Sun regularly ejects fragments of its thin outer atmosphere, or corona, in a phenomenon known as coronal mass ejection. Because the Betelgeuse surface mass ejection ejected 400 billion times more mass than a typical coronal mass ejection, those events are orders of magnitude weaker compared to what was observed on Betelgeuse. This explains why by mid-February 2020, Betelgeuse had lost roughly 3 times the brightness from magnitude 0.5 to magnitude 1.7 after starting to diminish sharply in October 2019. Betelgeuse's brightness had been stable for nearly 10 days and the star had begun to brighten again. However, Betelgeuse emerged to have ended dimming completely 5 days later, essentially ending the dimming episode. Because there were no notable changes in the infrared on February 24, 2020, it appeared that the recent visual fading was unrelated to the anticipated core collapse. Another research that day found that the star's dimming was probably brought on by huge grains of circumstellar dust occluding. The study employs measurements at sub-millimeter wavelengths and rules out dust absorbance from having a significant impact, although the fading looks to be driven by big star spots. Additional investigation revealed a sharp increase in Betelgeuse's brightness. On August 30, 2020, astronomers announced the discovery of a second dust cloud coming from Betelgeuse that was connected to a recent significant dimming of the star's light. In June of last year, it was suggested that a core patch on its photosphere might be the cause of the dust. And in August, a second independent investigation supported the initial hypothesis. According to research done in 2022 with the Hubble Space Telescope, the dust is believed to have been produced by the gas that the cooling star ejected. Astronomers have now produced a viable explanation to explain the disruption, which shows the blast's full magnitude. These results offer light on how red stars age and lose mass, which ultimately leads them to exploding as supernovae when their nuclear fusion engines run out of energy. The amount of mass loss is a key factor in determining whether red stars will survive. A large loss event is not always an indication of an impending explosion, just as Betelgeuse's unusually nasty behavior is not a clue that the star is about to become famous overnight. Betelgeuse is currently having difficulty healing from this damage. Although our Sun frequently experiences coronal mass ejections that blast off small pieces of its outer atmosphere, astronomers have never seen such a significant proportion of a star's surface layer get thrown into space because of surface mass ejections and coronal mass ejections. A big star surface mass ejection has never been seen before, according to experts. But there's still something happening that we don't fully understand. Hubble might be used to directly monitor this novel phenomenon and identify surface properties. NASA's Webb Space Telescope should be able to view the ejected debris in infrared light as it continues to drift away from the star during the real-time study of the creation of stars. Despite being far away, Betelgeuse is one of the shiniest stars in the sky due to its brightness, which has finally stopped declining and may allow it to retake its position as the 10th brightest star in the sky. Fuel must be spent swiftly to keep up with Betelgeuse's great energy, hastening its death. Such brightness comes at a cost. Betelgeuse will become extremely bright for a few weeks or months before the star ultimately runs out of fuel and explodes into a brilliant supernova. During this time, it may even become as bright as the full moon, making it visible throughout the day. Betelgeuse's explosion won't affect or even partly end life on Earth because it will take place too far from the planet. Astronomers estimate that a supernova must be 50 light years away for humans to be in danger, and Betelgeuse is over 10 times farther away. Instead, everyone on Earth at the time will be treated to an incredibly breathtaking view of a very bright star in the night sky. Please share your views in the comments section. If you have reached this far, like this video, subscribe to our channel, and press the notification bell so you may not miss any future updates. See you in another video. Until then, take care.